Okay, so let's look at an overview of process activities. So real software process activities are a combination of different things. There are technical activities, collaborative activities, and managerial activities. So we have a goal of producing our software by specifying, designing, implementing, and testing. So, all those same features, and then evolution follows that. So during this class, we are going to look at the different process activities that we have in the areas of specification, development, validation, and evolution. So let's start with an overview of our requirements engineering process. So we want to start out and elicit our requirements. That means talk to the customer, ask questions, analyze what they're asking for, come up with a set of written specifications, go back to the customer, say, did we capture what you wanted to do? Finally come up with a document and then validate that that's really going to provide the solution, and then go back and forth. And in the processes, we're going to end up with system descriptions, user and system requirements, and eventually some kind of requirements document. And think of that document in loose terms. It doesn't necessarily need to be some big book kind of document. It could be a database. It could be tasks that are broken down in different ways. I think I covered all of this, but just want to reinforce the validation. The validation is saying, is the software doing what the customer needs it to do? Not that it doesn't have any bugs, but that it actually meets the needs and satisfies the requirements. So our next step, we're doing our software design and implementation. And that's our process of converting the system specifications into executable code. So we need to do design, and that includes some architecture decisions. We want to design a software structure that can realize that specification. Then we start translating that into code that becomes a program that we can run. The activities of design and implementation are closely related and become interleaved. So here's the general process. We're starting out, we make some decisions on what platform we're going to use, what are the requirements that we need, and what kind of data. And that brings us to our design, where we decide in our architecture, what modules are we going to use, what kind of infrastructure we're going to use. And then between those modules and between the customer, we need some kind of interface design here. And then once you know how those are interacting with each other, then we know the interface for our components, and we can start designing our individual components. And almost all software systems rely on a database now for storing their data. Just like in your class, we're going to use databases once we get to our Agile project. And so we need to design the database and how that data is going to be stored. And the result of these activities, we're going to end up with our system architecture, our database specification, all those ER diagrams, our interface specifications, what calls can we make, what are the user interfaces, and then what each component is going to do. And then that work can be divided out to different teams to work on the components. So this should be capturing what I talked through on the graphic. And I think I covered this too, except I didn't really talk about debugging. Debugging is when you're trying to find out what's going wrong with the program and fixing it. Debugging is an activity that correlates to testing, because when testing occurs, bugs are found, and then as a developer activity, you go through the code and debug to find and fix those bugs. But debugging and testing do not mean the same thing. Testing is the act of exercising the program, where debugging is finding those faults and fixing those faults. So that part fits under the system implementation. Okay, so then our next step is our software validation. So software validation generally includes V&V, verification and validation. So it's intended to show that the system conforms to the specification and meets the requirements of the system. So this involves checking and reviewing processes, system testing, where all the components are put together and tested together. System testing usually has test cases that are derived from the specification, trying to use real data to be processed by the system. Testing is the most commonly used verification and validation activity. Let's look at our stages of testing. We can do component testing, and frequently that's done with a set of unit tests created by the developer. And then depending upon how the organization is structured, could have some test engineers also testing that at a component level. System testing, if you're a bigger company, usually moves into a different group where the components are put together, and the system testing makes sure that from component to component that overall the system works correctly. And then acceptance testing is testing with the customer's criteria in mind. Does the program do what the customer wants? Is it acceptable? Will the customer take that software and then use it for their company? Are they going to accept it because it works and supplies the needs of the specification? And hopefully I covered that in the graphic, but I have the words here for you. Testing in a plan-driven model. If you're using a plan, you start out creating your requirement specification, and as you create that specification, your test group at the same time is taking that and starting to develop an acceptance plan. And this acceptance test plan can even be used with the customer for the customer to say, yes, that is what I expect, that is what I want the software to do. So between the requirement specification and the acceptance plan, you can develop better requirements. So once the acceptance test plan and requirements are underway, then we can move on to system specification. And as that system is specified, then you can start writing a test plan for those system tests. How are all those pieces going to work as a system? Then once you get into the design, then you can start writing test plans for those subsystems that are going to be part of the overall product. And as you get into the detailed design, now you're at the developer level, and they'll be writing those unit tests with the code. And then when you are to the point where you have some code to test, all those plans have already been generated, and they start running those tests and see if they have, in the end, your service or your product that will meet the customer's needs. Okay, and so then the last of our software processes is our software evolution. Software is inherently flexible and can change. That doesn't mean it's cheap to change. That doesn't mean it's a great idea to always be rewriting your code. But the fact is that we can type in some more code and we can change any program. As requirements change through changing business circumstances, then we also have to support those business changes, and that software must evolve. Even though we mark the difference between development and evolution, it becomes increasingly irrelevant because there are fewer systems that are completely new. almost all software is an evolution. So here's our graphics. We have a system. We're going to define some new requirements. We're going to check how the existing system works, propose what we're going to change, make those changes, and come up with a new system to keep evolving our software.